Okay, we're going to go straight back into it here. And so our second example, we invest 10,000 Rand at 9.6% per annum compound monthly. How long will it take for the investment to double in value? And, my assumption is that you've made an effort. You're not just watching and copying down. So that's why I'm just running through really what the answers are. So we've taken 10,000 Rand. We've invested it at 9.6. Now be careful, that's 0.096. 0.96 would be 96%. That would be great. And it's compounded monthly, so 12. We don't know how long that's going to take, so we've just got N, and it's going to double, so it's going to get to 20,000 Rand. Okay, kind of makes sense there. So let's work through step by step. Let's divide both sides by 10,000 to start with. So we got 20,000 over 10,000. So I'm going to do it in the calculator in a second, but you might be tempted just to go, well, I can kind of do that in my head because 20,000 over 10,000, well, that's 20 over 10, which is 2 over 1, which is 2. And this is always going to be the case. But, let's just plug it in here and go 20, 1, 2, 3, divided by 10, 1, 2, 3. As long as you punch in your calculator correctly, not much lost in terms of just doing it like that. 1 plus 0.0. 9. Well, I'm actually, this part over here, I'm going to put that in my calculator just so we kind of have a sense of what that looks like. So we've got 1 plus 0.096 divided by 12. So that's 126 over 125 to the n. Now, previously, we might have done these and they always kind of worked out nicely, and we would have had something would have been a nice power of n to get 2 or something like that. But now we've got logs to the rescue, and kind of not whole point, but one of the points of logs is that we can get our exponent to be the subject of the formula. So in this case, n equals, and we're going to use log. Remember, the base stays the base. So this is our base, 125 or 126 of 125. And so we're taking the log of each side. So if we put that into the calculator, then now there may be just a little hint if we want them is using the memory functions. So I don't want to retype this, and I maybe don't want to use the ans button. So I might go shift store into A. So I know that that's A. So now when I take the log and I can go alpha A is my base because that's that number. So may or maybe not be useful. And so we're going to do that of 2, whether you did it with ans or you wrote it there, not a biggie, but those memory functions can be useful. So we get 86,989 blah, blah, blah. So therefore we can say that that's approximately equal. Let's do that on the next one. Approximately equal to 87. Now you think, what was our unit again? Well, we compounded monthly, so that's 87 months. So if we wanted to think of that as how many years, well, 7.24 years. So minus 7 times 12, 7, and 3 months. So 7.25 years, but 87 months. It doesn't say how many years, just how long. Okay, so then part B asks us, what interest rate per annum compounded quarterly would be needed to double the investment over the same time period? Okay, so our N has stayed the same now, and we're looking what interest rate compounded quarterly. So, one way would be to kind of think, well, let's use that formula again, but we can use our effective interest rate formula. So, 1 plus equals 1 plus that one there, and now we're dealing with our interest rate over 4 and our interest rate over 12 because that's our monthly. So what quarterly will be the same as monthly? Okay, well, our monthly we know is 9.6%, so 0.096. And what we don't know is that I on that side. Okay, so let's work this out. Now, I know that I've got this actually stored in the variable A, but I'm going to just retype it all. So our right-hand side is 1 plus 0.096 over 12, and we're raising that to the power of 12. So we got 1.1 what is that whole thing. So let me just show my thinking here. But how many of these steps you shows really up to you. 1,100 ... just to indicate that we're not rounding off yet. And now we're going to take the fourth root of each side. So, if we took the fourth root of that side and the fourth root of that side, we'll just be left with 1 plus I over 4. Then we're going to subtract 1 and then multiply by 4. So again, how many of these steps you show? Because of course you're doing it all in the calculator anyway. So we're going to take where's that fourth root? There it is. The fourth root of answer, because that's the previous answer in my calculator, 1,024. I don't want to write down each step because it just feels like a waste of time. So minus 1 gives us that, times 4 gives us our interest rate. I think it's often useful just to write this number down, 0.9677 blah blah blah. So therefore our interest rate is, and whether you write an equals or approximately equal doesn't really matter. And I'm going to just go times 100 equals 9,68 is what I get there, percent as our nominal, our quarterly. So in other words, going at 9,6% compounded monthly is the same as going 9,68% compounded quarterly. Feels very similar over the long term, and this would make more of a difference. Okay, that is that one. So I'll finish off with the making it maths. But there, we skipped it to stop. But how's that? See you in the next one.